Hey everyone, and welcome. Let's be honest for a second. Does the word algebra make you just a little bit nervous? If it does, you are in exactly the right place. Today we're going to take apart that anxiety and build a really solid foundation for mastering this stuff one simple idea at a time. So let's get into it. So let me just ask you right off the bat. Do you think you are bad at math? It's such a common feeling, right? This idea that some people are just born math people and the rest of us, well, aren't. But what if I told you that's just not true? Because here's the reality. Success in math is not some magic gene you either have or you don't. It's a strategy. It's all about having the right tools, the right habits, and the right mindset. And that's exactly what we're going to build together today. Okay, so before we even touch a single number or variable, we need a game plan. Section 1 is all about building your personal strategy for success, because how you approach the subject is half the battle. You know, a huge chunk of that math-related stress just melts away when you're prepared. Reading the section beforehand, showing up to class early, getting test dates on your calendar, these aren't massive, difficult tasks. They're small, simple steps that put you in the driver's seat before the lesson even begins. Now, during class, your main job is to just be present. That means the phone is out of sight, you're taking notes, and your brain is switched on. And taking notes isn't just about writing things down, it actually helps you process the information. But you want to know the most powerful tool you have? It's asking questions. Seriously, it's not a sign you're failing, it's a sign you're engaged and trying to learn. But here's the real secret. The learning doesn't stop when the bell rings. In fact, what you do after class often makes the biggest impact. A quick review of your notes each day, teaming up with a friend to study, and knowing where to get help, like your instructor's office hours, that's how you turn a concept you're kind of shaky on into something you really understand. All right, with our strategy locked in, let's meet the stars of the show. We're moving on to the actual building blocks of algebra, the universe of numbers. It all starts right here with the natural numbers. These are the most, well, natural numbers of all. They're the first ones humanity ever needed, the ones we use to answer the simple question, how many? You know, 1 apple, 2 rocks, 3 people. Super simple, super intuitive. But what happens when you have no apples left? For a long, long time, there was no number for that idea. The invention of zero was an absolutely massive leap forward for humanity. So when we take all those natural numbers and we add 0 to the group, we get the whole numbers. Okay, but what about owing someone $5 or the temperature dropping below freezing? For that, we need opposites. The integers include all the whole numbers plus their negative counterparts. And just like that, we can now describe things like debt or loss or direction. So what about all the space between the numbers on the number line? That's where rational numbers come in. Basically, if you can write a number as a fraction, it's a rational number. This group is huge. It includes all the integers we've already talked about and every decimal that either stops or repeats. It's how we talk about a third of a cake or 2.5 miles. This diagram just nails the concept perfectly. It's really like a set of Russian nesting dolls, isn't it? The natural numbers are tucked inside the whole numbers, which are inside the integers, and all of those are tucked inside the giant set of rational numbers. Each layer gives us more power to describe the world around us. So we've got our strategy, and we've got our players, all those different numbers. But if you just throw a bunch of players onto a field with no rules, you get chaos, right? That's why we need Section 3, the rules of the game. We're talking about the order of operations. Take a look at this expression on the screen. Yikes. Where would you even start? Do you add first? Multiply? Deal with that little floating 2? If we didn't have a standard set of rules, everyone could get a different answer from the same problem. We need a system. And that system is the order of operations, which most of us remember by PEMDAS. Please excuse my dear Aunt Sally. But think of it this way. It's the grammar of mathematics. It's a universal agreement that makes sure we all read and solve a problem in the exact same way, every single time. Okay, let's use PEMDAS to tackle our problem. First up is P for parentheses. The fraction inside is already simplified, so we're good there. Next is E for exponents. We've got 4 squared, which is just 4 times 4, so 16. Step 1, done. So what's next? M for multiplication. We need to multiply 6 by 2/3, and that gives us 4. See how the problem is getting simpler and less intimidating with every single step?
And finally, we're at the end, A and S for addition and subtraction. And for these, we just work from left to right. So 24 plus 4 is 28, and 28 minus 16 is 12. And there it is. By following the rules, we get one clear, correct answer. That is the power of order.
Now, PEMDAS gives us that strict order to follow, which is awesome. But math also has these really elegant, flexible properties that actually make our lives way easier. Think of them as shortcuts that are built right into the system. First, you've got the commutative property. All this says is that for adding and multiplying, the order doesn't matter one bit. -2 plus 7 is the exact same as 7 plus -2. It seems super obvious, I know, but it's a fundamental rule that lets us rearrange numbers however we want to make a problem easier to solve. Then there's the associative property. This one is all about regrouping. If you're adding a big long string of numbers, it doesn't matter which pair you add together first. You can group them in whatever way it is most convenient for you. It's another one of those tools that's all about simplification. And this table here just pulls all of those core properties together in one place. You can see the commutative and associative rules we just talked about, plus a few others, like the distributive property. Now, don't feel like you have to memorize this whole chart right now. The big takeaway is that these aren't just random rules. They're the fundamental truths about how numbers behave, and knowing them is like having a secret weapon. All right, this is it. We've talked about strategy, we've met the numbers, we know the rules of the game, and we have the properties that simplify things. It's time to put it all together. It's time to actually start speaking the language of algebra. You might see a formula like this for a cylinder's surface area and think it looks pretty intimidating. But let's really look at it. What is it? It's just an algebraic expression. It's got numbers, like the 2. It's got variables, those letters like R and H that are just placeholders for other values. And it's got operations that we now know how to handle thanks to PEMDAS. See? It's everything we've just learned, all combined into one useful recipe. So remember, all the things we've covered today, your strategy, the different types of numbers, the rules, they are not just abstract ideas from a textbook. They are powerful, practical building blocks. They are the tools you need to solve real-world problems. So the only question left is, now that you have these tools, what will you solve with them?